Hi, this video is about heating and insulating buildings. There are many ways that heat can escape out of one's home, and there is an incentive to reduce the amount of heat loss because heating a home is expensive. Some ways to reduce heat loss are more cost effective than others. The most cost effective methods will give you the biggest annual saving per pound spent. We can work out how long it takes for the savings to cover the cost of purchasing/implementing a certain method. We do this by using the formula below. This is the payback time in years equals the initial outlay, which is the cost of purchasing/implementing a certain method, divided by the annual saving, which is the saving per year of implementing this method. So let's have a look at a few different methods for reducing heat loss from a home. The first method is loft insulation. This is a layer of fiberglass wall laid out across the whole floor underneath the floorboards to reduce conduction and radiation. Loft insulation tends to be fairly cheap and has a fairly short payback time. The government used to engage in a scheme whereby they would pay half of the cost to individuals who got their lofts insulated. We are going to use loft insulation to see what the payback time is. Suppose that the cost of loft insulation was £160. The saving from loft insulation was £40 per year. We find the payback period by doing the initial outlay, which is the £160, divided by the annual saving, which is £40. So we get 160 divided by 40, which gives us a payback period of 4 years. Another way to reduce heat loss is to have double glazing windows. Replacing windows is very expensive and the saving per year is relatively low compared to the initial outlay. Therefore, the payback time for double glazing is fairly long. Curtains are another way that an individual can reduce the amount of heat lost in their home. This is because windows are in contact with the outside and are considerably colder than the inside of the room. If there was no curtains, then the windows would cause the room to drop in temperature because of conduction and radiation. Curtains provide an air buffer against the cold glass in the windows, thus reducing the amount of heat loss. They are also cheap and provide a fairly significant saving, meaning that the payback time is low. Another method to reduce heat loss is to install cavity wall insulation. In older homes especially, there is a cavity in a home's exterior walls. You can fill this void with foam, which reduces the heat loss. The payback period for cavity wall insulation is between 5 and 10 years. Another method to reduce heat loss is draft proofing. We can measure how fast heat can move through a material by using U values. The higher the U value is, the more heat is transferred through the material. Metals are good transferers of heat because of their free roaming electrons, and this means that they have a high U value. On the contrary, insulators, which are poor transferers of heat, have low U values. Loft insulation is a poor conductor of heat and therefore has a low U value. We are now going to take a look at specific heat capacities. Different substances require different amounts of energy to heat them up. For example, to heat 1 kilogram of water up by 1 degree, we need 4,181 joules of energy. 1 kilogram of oxygen, and again to heat it up by 1 degree, we need 918 joules. And for lead, it is 128 joules to heat 1 kilogram of lead up by 1 degree. We can work out how much energy is needed to heat up a certain substance of a certain weight up by a certain number of degrees. We do this by using the formula below. E equals m times c times t, where E is energy transferred in joules, the amount of energy that is needed, M is the mass of the substance measured in kilograms. C, which is the specific heat capacity, which is the amount of energy that is required to heat up 1 kilogram of this substance up by 1 degree. And the final one is T, which is the temperature change. So that's the change in temperature. So let's have an example. Let's work out how much energy is needed to increase the temperature of 4 kilograms of water from 15 degrees to 30 degrees. So to answer this question, we use the formula above. The mass is 4 kilograms because we have 4 kilograms of water. The specific heat capacity we've got in the example above, which is 4,181 joules per kilogram per degree. And finally, the temperature change is 15 degrees because the water is being heated up from 15 degrees to 30 degrees. So 30 minus 15 gives you 15. So we do 4 times 4,181 times 15, which gives us the energy required, which is 250,860 joules, or 250.86 kilojoules. Water has a high specific heat capacity, which makes it useful for storing heat energy. Also, it is a liquid, which makes it easy to be transported, and this is why water is used for central heating.